Hello everybody, welcome again to my channel here. In the previous video, we learned about manually tuning the hyperparameters. Okay, now we're gonna see automatic tuning of hyperparameters. Okay, the first thing, and there are like we'll see three things here. We'll see the base search, cross-validation technique. We'll see the grid search, and we'll see the randomized search technique. So first thing is with the base search technique. Okay, so. Um, So as we, as I mentioned earlier about manually doing it, here also we are doing the same thing. We are first need to define the search space here. Okay, the search space is something where the algorithm will look for, or with the range of values between which the algorithm will look for. Okay, the best value. Okay, so here also I'm gonna take the C, gamma, degree, and kernel method. This is actually the SVM. Let me see. Yep, this is this support vector machine. Okay, so here the first parameter is I take C parameter, regularization parameter. It's the log. I take the I'm taking the log values here from 1e minus 6 to 100. Then the gamma, the same thing at degree 1 to 5, kernel, linear, polynomial, RBF, or sigmoid. Then there is I'll define the evaluation method here. I'm using repeated stratified k-fold method, with 10 splits and 3 repeats and repeated 3 times. The random state one. Then I'll define the search method here, so that I'm going to use the base search CV method that is from the SKOPT class. Okay, and here I have let me show you here this here. There you go. So the parameters are the estimator object when where the so the algorithm actually needs to know which method or the model which you are using for optimization. So here we're using the SVC method, the support vector. Um, then the search spaces. The search spaces could be dictionary, list of dictionaries, list of tuples. Okay. Then what have we taken here? Then I've taken n jobs equal to -1. That's -1. The value gives you the maximum number of cores that are in your system. They all work together to give you more parallel processing time here. Okay. Let's see. This is the cross-validation method which you're using, which is this one. So once you define all the search here, then you perform this. Then you fit the this thing here. Um, just like you do it in the machine learning models there, you fit it um, and the features and the target variables. Okay, X and Y are the features and the target variable, and then you print out the best result. And the best result is printed out by just having this variable and dot best underscore score underscore, and the best parameters you get it like the same thing, dot best underscore params underscore. So we get 92 percentage scored here. That's the accuracy, and the best parameters are the C. For C, it's 0.001207. Then to degree, it's 2. Gamma value, it's 4.023203. And for the kernel, it's the polynomial kernel. So this is how you use the base search cross-validation method to get the best hyperparameters out there for your model there. Okay, yeah. And the next thing I have for you is the grid search cross-validation method here. It just takes in the same thing as the base search did. Just the it comes from a different place there. It's from sklearn.model selection, and from there you import the grid search CV, and you do the same thing here. You define your search space in a dictionary. Give all the ranges for all the parameters you want and define your model. And then you do the cross validation technique, and then you fit the model, and then it goes away. For the best parameters and the best scores, you again use the same thing here, CLF, which is this thing here, dot best underscore params underscore. This gives you the best parameter. This for C it's 100, the degree is 1, gamma value is 1 e minus 6 minus 06, and the kernel it's linear. And the best score, the score accuracy is 88.33%. Okay, it's pretty okay, not bad. Okay, the next thing method comes to be a randomized search CV. So as I mentioned in the previous videos, that the grid search CV is when you actually have a little idea about these ranges here. That is where you use these methods. And the random search is when you have no idea about what's going on here, when you have like a bigger range here. I've not taken a bigger range here, but yeah, it's actually faster than I'm sorry, it's not faster, but yeah, it's actually better when you do not know anything about the ranges, and you're just clueless there. So this is where the differences between the randomized search and the grid search method come. This is the advantage of the randomized search method. Okay, yeah, you do the same thing here for the randomized search also, and gives you the same thing. Um, yeah, but if you use this thing, I also used it on a random forest classifier model here. So I have imported the random forest classifier class, and then I have made a dictionary for the hyperparameters. There's a bootstrapping. If I want to do a bootstrap, yes. Maximum depth, I have 6, 8, 10, 12, 14. These are just the values which I have given according to my intuition there. Then the maximum features would be, if it either would be auto, square root, or log. Then the minimum samples underscore leaf 2, 3, 4. Minimum sample split 2, 3, 4, 5. Then n estimators. Yeah, this is my search space. Then I've taken the model, initiated the model here, then ran the randomized search CV for hyperparameters optimization, and put out all the values here. This is the model here. This is the search space, the number of iterations, whatever you want. I mean, it's according to your intuition there. Then the scoring, verbose, cross validation, number of cores, number of jobs, random state 42. Then you just fit the model and it runs. Then you get the best parameters here, and the score is 94%, which is very good there. So yeah, this is how you can use hyperparameter optimization on your different machine learning models here. It's pretty good, pretty handy method, and it's pretty easy. We can use it on multiple machine learning models. All right. Okay, guys, that's about it for this video. If you guys liked it, please like, share, and subscribe. And also, if you need anything, if you need me to make any more videos regarding any other topics related to machine learning and data science, please don't hesitate to put that in comments there. Until next video, guys. See you. Bye now.